Alright, welcome back. It's time to get started on our second video for Chapter 2. And in this particular video, we're going to start talking about expressions and arithmetic, or doing a little bit of mathematics. Now that we know about variables and data types, we're going to start to put those things to use. So, let's get going. It probably doesn't surprise you that computers are good at math and logic. That seems to be the logical, if you will, thing for them to do. And we're going to find out how to do that. So the way we do that is via expressions. And expressions are just little pieces of code or program that we write, and then the computer evaluates those expressions when the program runs. So it's like a little sentence, if you will, made up of variables and other symbols and constants, and the computer takes all that and figures out what the answer is, if you will, to that little sentence. So it's a little mini problem, a math problem that the computer has to figure out based on the values of the variables and constants and the expressions or the operators that are used. Okay, so we've got several types of these expressions that we're going to deal with. We've got mathematical, which is the focus of this video, and then we also have Boolean and relational, and those will be the focus of the next video in this series. So let's talk some more about math or arithmetic. Processing has four basic operators that we're used to from normal calculation. So if you used a calculator before, you certainly will understand these four operators. And then it has one that may be new to you. So 5 total basic mathematical operators. Okay, we've got addition, which we use the plus sign for, subtraction, minus sign. Multiplication, now when we do multiplication in programming, we generally use the asterisk or the star to indicate multiplication rather than an X, so we don't get it confused with the letter X. Then we have division, which we represent by a forward slash, or the lowercase of the question mark key. And the one that's probably new to you is modulus, which we represent with the percentage sign, and that's the remainder after a division. And that turns out to be a really handy operator, and we'll talk about that here in a little bit. So let's look at some examples. Here's a simple mathematical expression, and this could be something put into a processing program. It's like a problem that the programming language has to solve, or the computer has to solve. And so when you see the expression 2 plus 3 in a program, when the program runs, the computer evaluates that and of course gets the value 5. That makes sense. Similarly, if we have 13 minus 3, well, then the computer looks at that little problem, solves it, and comes up with the value 10. 4 times 3, remember we use asterisk for multiplication, it's going to be 12. 5.0 divided by 2.0, notice that we're using floating point numbers there instead of integers. That's going to come out to 2.5, which we expect. But there is a wrinkle with division, and that's what happens when we do this, 5 divided by 2. The thing to look for here is that both sides of the division operator are integers, the 5 and the 2. Neither of them have a 0.0 after it. So when we have that situation, when both sides of the division are integers, then it's an integer division, which means that we get rid of any fractional component. So the answer to that problem is 2, not 2.5. Okay? So if we need to have fractions and division, we have to make sure that at least one of the sides of the division operator is a float instead of an int. If they're both ints, we get integer division. All right, last operator then, in its basic form, is the modulus operator. So 5 mod 3. 5 mod 3 means take 5 divided by 3 and give me the remainder after the division. So 5 divided by 3 is 1 with a remainder of 2, therefore the value of 5 mod 3 is 2. Okay? So those are all really pretty straightforward as long as you realize the little kink with floating point numbers and division, and other than that, things will go as you expect. Now, it gets a little more complicated when we start to string things together. So 5 times 3 minus 2. There's two different ways that that expression could be evaluated depending on which of the operators we do first. If we do the multiplication first, 5 times 3 is 15, minus 2 would be 13. On the other hand, if we do the subtraction first, then 3 minus 2 is 1, and 5 times 1 is 5. Okay, so it is a different answer depending on how we evaluate the expression. Well, computers aren't really good with ambiguity, so we have what are called precedence rules, which tell the computer exactly what needs to be done next. All right, and here's how they work. First of all, if we have expressions that involve parentheses, then we would do the innermost parenthesized sub-expression first. Okay? Second level then would be are things that involve multiplication or division. Multiplication, division, modulus. Those would be the next priority. And we would do those from left to right if there's more than one. That's generally the case. If we have things that are equal precedence, then we just do them from left to right. And lastly, then we'll evaluate all of our pluses and minuses. And again, left to right if there's more than one. So let's look at some examples. We'll start with the previous example that we looked at, 5 times 3 minus 2. Okay, so our precedent rules tells us that the multiplication is going to happen first, giving us the 15, then the subtraction. So our answer for that example is 13. Okay, what about something a little bit more complicated? 1 plus 2 minus 3 times 4 divided by 5 modulo 6. There's our expression. Okay, the rules tell us that we're going to do all of our multiplication, division, modulo things first, and since there are 3 of them, we'll do them from left to right. So our first expression or sub-expression that will be evaluated is 3 times 4, giving us 12. Next we'll do 12 divided by 5. Now be careful. What's 12 divided by 5? It's integer division. Therefore 12 divided by 5 is 2. We don't have any fractional component. And finally then 2 mod 6. Well, 2 divided by 6 is 0 with 2 left over. So 2 mod 6 is 2. Now in the expression all we have is pluses and minuses. So we'll do them in order from left to right. So 1 plus 2 is 3. 3 minus 2 is 1. Easy, right? Okay, and remember we can have parentheses. And so in this situation we've got a multiple parentheses expression, 2 different levels of parentheses. So we'll start on the inside, innermost, and work our way out. Therefore the 1 plus 2 happens first, giving us 3. Now our next parenthesized sub-expression, 3 times 3 is 9, and lastly 9 minus 4 is 5. Alright, so just remember that we do parentheses first, starting with the innermost, then multiplication, division, modulo, and finally plus and minus. And in any case where there's more than one of those, we evaluate the sub-expressions from left to right. Okay. Now, what we have to spend the rest of this on is unary versions. And there are unary versions and shortcut operators that we have to talk about that make things a little bit easier for us, a little bit easier to type, but also can be a little bit confusing if we use them incorrectly. So, starting with unary. There's a unary version of the minus operator, and we use that to change the sign of a number or a variable. Okay, it's the minus sign, like you see on a calculator. So, for example, a unary minus with the number 13 means that's minus 13 rather than positive 13. X plus minus y, now I'm using variables in my expression, which is totally fine. But now what I'm saying is invert the sign on y and add it to x. Okay, there also is a unary addition symbol, but it's kind of silly to use it because it has no change on the sign at all, so don't bother. Now, let's talk about shortcuts. Okay, a lot of times when we do programming, we're going to find ourselves incrementing a number by a certain amount. So this expression here, notice that it has an expression and comments. Everything following the / is a comment, which is to be ignored by the computer. And this says take the variable x, add 10 to it, and then store the result back in x. Okay, so whatever is originally in x, add 10, store the value back in x. The result is that I increment the value of x by 10. Well, that's something that we do so often that processing and languages like it, like Java, C++, and C, have shortcut operators to save us a few keystrokes. We're lazy as programmers sometimes, and so we want to type as little as we can, and that helps us in that regard. Okay, and so here's an equivalent statement. X plus equals 10. Does exactly the same thing, and it saves us, 1 or 2 keystrokes when we're typing. It's a little more compact, and so this is the preferred way to do an increment. Now, there are equivalent things for all of our basic mathematical operators. So we've already seen plus, but we can do a decrement with minus equals, multiplication with times equals, division with divide equals, or modulus with mod equals. But the plus or minus are the ones we're going to use most often. And again, it's okay to write the expressions the other way if you're more comfortable with them. It's just that these things would be more likely to be seen in professional programming because people are used to using them. Okay. Even more frequently, we do our increment or decrement by 1 instead of some other value. So like x equals x plus 1 or x plus equals 1 would be examples. So for increments or decrements that involve 1, we have another shortcut operator, plus plus and minus minus. And if we use them sanely, they're pretty straightforward. If we start to get fancy with them, then they get a little complicated. So, again, here's our initial expression, x equals x plus 1. Perfectly fine, nothing wrong with that. Works. We could shortcut that with x plus equals 1, or we could do x plus plus. Okay? The thing is that that's not exactly the same as x equals x plus 1. And we'll get to that. And this is why. We could also do plus plus x, which seems very strange, but has the same effect on x. Ultimately, x has its value incremented by 1. And the same thing would work for decrement, minus minus. Okay, so if we're just using x plus plus like that, not in a larger expression, then it's fine. But if we start to use plus plus or minus minus in larger expressions, then it gets a little bit harder to keep track of. So when we do x plus plus, what that means is in the larger expression, use the value of x first, then increment it. On the other hand, if I do plus plus x, that's pre-increment, which means I do the increment first, then use the new value of x in the expression. So let's see how that works. I'm going to start out with a variable x set to 5. And now the question is, in this expression here where I declare my variable y and give it the value of this expression, what is y's value? So x plus 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 3. Okay? X plus plus means that's post-increment x. So I use the value of x first in the larger expression and then increment it. So x's value is 5. 5 plus 3 is 8. So y's value will be 8. And then x's value gets incremented to 6. Now in this case, this next expression, x's value is 6 at this point, but the plus plus is pre-increment, so I add 1 to the 6, giving me 7, and then 7 is the value used in the larger expression, so 7 minus 14 Z's value should be -7. That's a typo. My bad. That should say -7 right there. And I'll try to fix that on the slides as they come out. So right now, just imagine drawing on the screen a negative value right there. Okay? Other than the little typo there with the -7, that illustrates how these pluses and minuses work. All in all, we should usually plan on using them just by themselves, x plus, and then we don't have to worry about them in the larger expressions. We don't have to get too cute. Alright, our next video in the series will be talking about Boolean expressions and relational expressions. And that's where we're going to talk about things which are true or false and how to compare items. So, until then, have fun.